once you are ready to go. Okay, so we have already exposed you guys a little bit to dot plots when we first started statistics. Today we're going to talk about creating one, interpreting one, and comparing one. So there's going to be a few things that you guys might not know or have heard of, and then there's going to be things that you're like, yep, I either remember this from Imagine Math or I remember this from the last time we talked about dot plots. So when you are creating a dot plot, you essentially use what kind of line? What kind of line do we use when we create a dot plot? Sophia? Number line. Does our number line have to start at 0? You're saying no? Does not have to start at 0. It actually just needs to be within the range of your data points. You can skip numbers, but it makes it really, really hard to kind of figure out where those numbers go. So my recommendation is definitely to try not to skip those numbers, but again, if you do, you do, that's your choice. So we're going to be using this data set to create a dot plot today. So it says the data set below represents the height rounded to the nearest inch of students in Mr. Hansen's homeroom. Create a dot plot to represent this data. So the very first thing that we need to do is put our numbers in what kind of order? What kind of order do we need to put them in? Mainly just to help us with organizations, right? Yes. So let's go ahead and I have a cheat sheet and I'm going to use it today because if I don't, I'll feel I mess up. I had a cheat sheet. All right, so again, we're putting our numbers in order from least to greatest.
Tyler Hargrove. Please report to the band room. Tyler Hargrove.
So we're starting with 55. And what I recommend you do is go through and cross off your numbers as you put them in order. That way, if you're going through and you're crossing them off and you get to a number and you realize, oh my goodness, I left this number out, you can at least kind of put it where it kind of needs to go. But if you just trust that you've hit all the numbers correctly, you're probably going to miss one. All right, so 55. Then we have 56 and 56. So 56 is there, 56 is over here. Then we have 58, 58. Then how many 59s do we have? How many 59s do we have, Gabby?
3.
We have 3. So then cross off 59, 59, 59. All right, what number is going to come next? Kira?
60.
How many 60s do we have?
2.
So 60 and 60. Okay, what comes next? Savannah?
61.
How many 61s do we have?
4.
So I have 1, 2, 3, 4. Okay. How many 62s do we have? Count your 62s. Caitlin? For sure. So we have 6 62s. 1, 2, 3, 4, 5, 6. And like like I said, that's why it's really important, guys, to cross off your numbers as you're going, because it also makes it a lot easier to see where you're at with your numbers as well. All right, do we have a 63? No 63. And then we have 164 and 165. Okay, so give me a thumbs up when you have these written in order. Okay, so our smallest number is 55 and our biggest number is 65. How many lines do we have? Count your tick marks on there. Because we know we gotta start with 55. How many lines do we have? We have 10, so that actually works out perfectly. 13? We have 13, just kidding.
Yeah.
13, sorry. We have 13, which works out perfectly. So we're just gonna go ahead and we're gonna start with 55, 56, 57, 8, 9, 60, 61. If you write big, this is gonna be a struggle, and I'm sorry. Bless you. And then what do we do from here? So we have our number line, we have our data set, we put our numbers on our number line. At this point, this is where you create your dot plot. So what are we gonna do, Callie?
So the number, so the amount of numbers that you have on the you took out many dots.
Yes. So Callie, for 55, how many dots are we gonna put above 55? Just one. So we're gonna put one dot right there. Please go ahead and use your colors so they do stand out a little bit. All right, how many 56s do we have? How many 56s? Two, so I'm gonna put 2 dots. All right, how many 57s? None, so I skipped that number, right? Okay, how many 58s do I have? 2. Oops. How many 59s? 3. How many, excuse me, 60s? How many 61s? 61s? 3? 4, sorry. I heard, the first time I heard 1, then I heard 3, I wasn't sure what was going on over there. Yes, we have 4. All right, how many 62s do we have? How many 62s? Andrew? How many 63s? 0, so I'm gonna skip that one. How many 64s? Kira? And how many 65s? Savannah? Alright, so you have officially taken data and created a dot plot. How do we feel about that? It's pretty easy. It's not hard. I mean, it really isn't. I would say the hardest part is not skipping a number or forgetting a number. That's going to be the hardest part. All right, give me a thumbs up when you have this done. All right, so the next one we're going to is going to be interpreting a data plot. So this is a data plot, a dot plot. So this is where you are going to hear some new words today that you've never heard before. All right. So it says, the dot plot below represents the latest test scores for Mrs. Miles' first period civics class. Use the dot plot to answer the questions to the right. So this dot plot's already done for us. And we're gonna use this data to answer these questions. Alright, so the first one is one that you're not, I don't know if you've heard this before, but it says, describe the shape of the dot plot. Are the dots evenly distributed or grouped on one side? So looking at our data, stand up if you feel like they're evenly distributed. Nobody? Okay? Yes or no? You don't know? And that's okay, because again, these are words that we haven't heard. So it's okay if you're like, I'm not exactly sure. Alright, stand up if you feel like they're grouped on one side. Okay, the data is grouped on one side. It's grouped to the right. We call that skewed to the right. Skewed means it's more to one side or the other. Alright, so for A, you're going to write S-K-E-W-E-D. So that's skew or skewed to the right. Because the majority of the data is where on our dot plot? Gabby? To the right side. Okay? Alright, so now it says describe the center of the data. So the center of the data is dealing with mean, median, mode, and range. So how do we find the mean? What do we have to do? What would we have to do here?
Add all the together and divide by
Okay, so when we add all these together, you get 1,735. Someone please count the number of dots we have. Count the number of dots we have. And then raise your hand and let me know. Alright, Ramon?
21.
21. So we're going to take 1,735. I already did the work for you. What?
Are we counting the outlier right now?
Yes, because it's part of our data. Okay? So we take 1,735 and we divide it by 21. And our average for our scores is 82 6 tenths. Now looking at our data, so looking here, because yes, the outlier is way over here, we'll talk about that in a second. 82.6 is essentially about in here. Is that kind of the middle of our data? I mean, it's not exactly the middle, obviously, because what is exactly the middle? Which one is exactly the middle? I'm not asking for a number. Which one of those is exactly the middle? Elizabeth? I'm not asking for a number. Stop counting the numbers. Which word is exactly the middle, y'all? Isabella? Median. The average or the mean is around the middle. So again, 82.6 is about here. Is that close to our middle? Your answer should be yes. It's not a trick question. All right, so our median. Raise your hand and tell me, how do we find the median of our numbers? Or of our data set, sorry. How do we find the median? Bryson?
You have to cross off the numbers until you find two same numbers and then
So I just start here, start crossing off numbers?
crossing off the dot.
Okay, so I start here, start crossing off dots?
And then start to the left and then the right.
Okay, so front to the back. So I'm just gonna cross these off until I get to a number in the middle. All right, so then what number is our median? What number is our median? Levy? 85. So 82 6 tenths is fairly close to 85. So we know that our mean and our median are good to go. All right, how do we find the mode? Because there's a lot of dots on here. So how do I go about finding the mode here? What am I looking for? I love that I see some people looking back in their foldables, and that's exactly why you have it. Andrew?
So you're looking at your numbers, and whatever number like repeats, you circle those.
Okay, so I have 140, I have 165, I have 270s, 175, I have 380s, 5 85s, 4 90s, 2 95s, and 2 100s. So Andrew, I have 1, 2, 3, 4, 5, 6 modes.
So you back them all up and
For mode, boy, you better get that foldable out. I'm waiting. So I have 6 modes. No, child. What is mode?
then
Most, right? So, Andrew, which one has the most? 85. So, Andrew, what is our mode? 85. All right, and then the range. How do we find the range? What do we do here? How do we find the range? Isabella. Okay, what's my biggest number? And what is my smallest? All right, so 100 minus 40 is going to give us 60. All right, so it says describe the spread of the data. Are there any outliers? So, how many of you guys have heard this word before, outliers? Okay, an outlier is a number far away from the data. So we do have an outlier, don't we? This poor Bryson over here who got his 40 because he didn't study like the rest of us. Just kidding. But no, this student clearly did not study, didn't do a very good job, and they have this crazy low score, which is bringing down the average of everything else, right? So our outlier would be what? So the outlier is 40. All right, questions about that? Seems pretty easy. All right, the last thing we're gonna do is we're gonna compare data plots and get some information from them. So flip up that last one. So we have 2 dot plots that, why do I keep calling them data plots? We have 2 dot plots that we're gonna be looking at. So it says the data below represents the shoe size of students in the girls' PE and the boys' PE class. Use the dot plot below to answer the questions to the right. All right, so here's the girls, here's the boys. So it says compare the shapes of the dot plots. So for the boys, or for the girls, what do you notice about the shape? What do you notice about the shape? All right, so this one goes up to a fairly good point and then comes down. All right, so where's the majority of our data in the girls' dot plot?
8, 9.
Okay, don't be as specific.
Oh, no.
In the middle, all right? So we're just gonna say girls, data majority in the center. All right, and then looking at the boys' data, where is our shape? Because it looks a little, to me, it looks a lot different than the girls, right? Where do you think the majority of the data for the boys is? Levy.
At either the right or the left.
So would you say the boys' data is skewed to the right? Okay. So boys' data is skewed to the right. All right, so it says compare the center of our data. So with the girls, the majority of girls wear what size? Majority of the girls wear what size? Ariana?
8.
So girls wear, oops, if I could spell today, that would be fantastic, y'all. So girls wear the majority, size 8. What do we notice about the boys? What do we notice about the boys?
They wear size 10s.
The majority of the data wears the size
Yes.
10?
That is like one of the largest numbers that they have. So,
But look at our data compared to the girls' data. The boys' data is a lot more even, isn't it? Between 9, 10, and 12, there's only 1 dot difference, right? So the majority of the boys' data is, we could just say, is a bigger shoe size. Because again, you look at me like I'm speaking a foreign language right now, really. There's 4 dots here, 5 dots here, 4 dots here. The majority of your data is not 10. The majority of your data is on the higher end. Because most of our data is on this side, where with the girls, it kind of peaks up and peaks down. It's symmetrical. All right, so boys, majority. Wear larger sizes. All right, now we have to find the median of the boys and the girls using our dot plots. So go ahead, stand up when you have the girls' median. What do you do when you have 2 numbers in the middle? Indira, add them and divide by 2. All right, so you should have got 2 8s in the middle. Add them together, you get 16 divided by 2, and you get 8. So the median for the girls is 8. All right, do the same thing for the boys. Stand up when you have your answer. All right, what do we get for the boys? 10. Did you find an even number or an odd number of medians? So since you found 2 medians, what do you have to do with them? And 5. All right, and then calculating the range for the girls and the boys. So what is the girls' biggest shoe? What's the biggest size on our dot plot? Elizabeth? Huh? 11. Minus, what's our smallest size on our dot plot? Bria?
5.
All right, so 11 minus 5 is 6. So the range for the girls is 6. All right, and then for the boys, same thing. Alex, what is our largest size? And I'm gonna subtract 6. 13 minus 6 is 7. So the range for that is 7. All right, questions about creating a dot plot, interpreting a dot plot, and comparing dot plots? How do we feel? Okay, all right, so don't put this away, but I want you to put it to the side and go ahead and get out your lesson 4 from today. Alright, so we're just gonna jump right in. It says 15 customers in a pizza shop were asked, how many toppings did you add to your cheese pizza? Their response are shown in the table. It says, could you use a dot plot to represent the data? Explain your reasoning. So, looking at our data, do you think you could use a dot plot? Give me a thumbs up if you're like, yeah, I would use a dot plot. Okay. Alright, why? Ben?
Because there are a lot of listed numbers and so it would be more efficient to use the dot plot.
You said N would be more efficient? Right? That would make me work. Alright, now it says complete the table. So this is a frequency table. And on a frequency table, you just put tally marks for however many numbers you have of that number. So how many zeros do we have? Let's go through. So we have 1, so I'm going to put 1 tally mark. Another one, put a tally mark. Another one, put a tally mark. Another one, put a tally mark. So, did I get all the zeros? Y'all gotta check me, because you know I can't read, count, nothing, so. Alright, I want you to do 1, 2, and 3. Go ahead and stand up when you have your data, your tally marks in your data sheet. Alright, Caitlin, how many ones did you have? So 1, 2, 3, 4, 5. Okay, how many 2s did we have? Alright, Soraya. 2. And then how many 3s did we have? Savannah? 2. Alright, we all agree? Slide over to the next part. It says, use the tables from the warm-up to display the number of toppings as a dot plot. Label your drawing clearly. Alright, so you have 0 to 6. How do we go about doing this? How do we go about doing this? Levy.
Well, you put 4 dots on your file.
So,
5 more.
right, so essentially we're just using the number of tallies and those tallies become a dot.
Yeah.
Okay, so let's go ahead. We have, Levy said we have 4 zeros, so put your 4 dots there. We have 5 ones. We have 4 2s. And we have 2 3s. What do we need to label our dot plot as so we actually know what the 0, 1, 2, and 3 means? What do you guys think? Andrew?
How many pizza toppings?
So pizza toppings. Alright, number 2 says, use your dot plot to study the distribution for the number of toppings. What do you notice about the number of toppings that this group of customers ordered? Write 2 to 3 sentences summarizing your observations. Alright, so what do you notice? What do you notice about your dots, your data?
Like, the more less the number, the more the dots that they have.
Okay, so the majority of people ordered no toppings, 1 topping, or 2 toppings. Okay, so that can be one sentence. Alright, what's another sentence? Again, looking at our data, looking at our dot plot. Sophia?
Most all of the data is on the website.
Okay, so we're gonna say most people ordered 0, 1, or 2 toppings. Our data is all on the left side. Could we even take it a step further and talk about the numbers that we didn't use? Like, what is 4, 5, what are 4, 5, and 6 representing on our dot plot? Gabby? Right, so did anybody that they surveyed want 4, 5, or 6 different toppings? So we can even throw that in here. So nobody wanted 4, 5, or 6 toppings. Because yes, we're obviously looking at the data, we're looking at the dots, but also don't forget about what the numbers are that aren't being used. Bless you. Alright, questions about the first 2 things we've done? So fairly easy, just kind of looking, comparing. Alright, let's go ahead and look at homework time. So we're going to skip down to 4.3. Says 25 6th grade students answered the question, how many hours do you generally spend on homework each week? Why is this question a statistical question? Ooh, taken aback. We all forgot what a statistical question is, right? No? Alright, so before you answer this question, tell me what a statistical question is. Alright, Joe?
A statistical question is a question that has more than one answer. It has more than 2 or 3. It can have multiple or just 2.
Alright, so we want a variety. We want that variability, okay? Just making sure. Alright, so then why is this a statistical question? Perfect. Alright, go ahead and flip your paper over when you are done writing that down. Then, right? Are you trying to collect apples like me? Can you collect apples? Alright, looking at number 2. It says this dot plot shows the number of hours per week that these 25 students reported spending on their homework. Alright, use the dot plot to answer the following questions. For each, show or explain your reasoning. What % of the students reported spending 1 hour on homework each week? What percentage of students reported spending 4 or fewer hours on homework each week? And then, so you're gonna answer A and B together as a group, and then stand up when you're done.
Guess what? Find percentage, and then you get my other notebook.
Yeah, I had a music notebook.
Oh, just so you guys know, if you find the number of, like for the first one, however many did 1 hour of homework, if you take 5 and divide it by your total, you get a decimal, that's your percentage.
Never mind. Thanks, Biscuit. Total number of people, yeah.
Take the total number, like, so for 1 hour there are 5 people, right?
Yeah.
So you're gonna take 5 divided by 25, so your 5 is going under your division house, and you're gonna get a decimal.
No, she said you're gonna get a decimal. It's not a decimal.
Yeah, but 5 divided by 25 is 5.
No, you're supposed to put the 5 under the division.
Alright, let me put y'all out of your misery, because this is scary.
I know, she's making me lose brain cells.
Alright, so how many people studied for 1 hour? Don't tell me the percentage, just tell me how many people. 5. So we're looking at this data set right here. So over here, I'm gonna show my work. We'll do 5 divided by 25. Obviously, that's not gonna work. It's taking us way back to division. I'm gonna put a decimal, bring it straight up. And then I'm gonna add a 0. How many times do we multiply 25 to get 50? 2 times. So this becomes 2/10. Well, I'm now gonna take my 2/10. I'm gonna move my decimal 2 places to the right, and I'm going to get 20%. That is how you do percent, super easy, not the way I taught you prior. So, the percentage is 20% of the students. Alright, what percentage of students reported spending 4 or fewer hours on homework? So 4 or fewer, so we're including 4, we're not including 4. Isabel. Alright, so we have 1, 2, 3, 4. So 4, 3, 4, 5, and then 1. There's Bryson again. Right? Oh, you're quiet today. She's not awake. Alright, so what's 4 plus 3 plus 4 plus 5 plus 1? 17. So, Kira, can I do the same thing I just did?
Yes.
Alright, so I'm gonna do 17 divided by 25. Alright, doesn't go in. I'm gonna put a decimal, add a 0. Well, how many times does 25 go into 170? If you don't know, do the math on the side of your paper, right? Andrew? Alright, so Andrew, what is 6 times 25? I'm gonna do minus 150, which is going to give me 20. I'm gonna add a 0. How many times does 25 go into 200? Real? 8 times. So I end up with this, move my decimal 2 places to the right, this becomes 68% of the students. Make sense? Okay. Number 3, it says, would 6 hours per week be a good description of the number of hours this group of students spends on homework per week? So looking at our data, so 6 hours, is that a good description that the majority of students, or the average student spends 6 hours? 6 is here. Look at our data. Where's the majority of our numbers? To the right or to the left? To the right or to the left, Alex?
To the left.
So that's probably not a great description, right?
Yeah.
Yes or no?
Yeah.
That's not, because the majority of, like, our median is probably gonna fall somewhere in between probably 2, 3, or 4. Alright, so 6 hours would not be, because the majority of our data is to the left. All right. What about 1 hour per week? So 1 hour is over here. So would that be a good estimate?
Yeah.
No.
No.
Why not? Just because it has the highest number doesn't mean it's a good description. Again, where's our median going to fall? Like, just kind of guessing. Joe?
In 4, around that maybe.
Probably between like 3 and 4, right? So, okay, so great, we have 5 people spent 1 hour, but that's not the majority of our data, okay? So kind of the same reason as the 6 hours. So 1 hour is not because more students spent more than 1 hour on homework. Whatever you're doing, stop, son. You need to be ready. Alright, and then you can go ahead and answer number 4. What value do you think would be a good description of the homework time of the students in this group? Because we've said it a couple different times now. So once you have that written down, go ahead and stand up for me. Alright, Andrew, what'd you write?
It would be around 3 and 4 because it's the middle of my data.
Okay, so between 3 and 4 because it is the middle of our data. Okay, and the last one, someone said, in general, these students spend roughly the same number of hours doing homework. Do you agree? Explain your reasoning. So how many of you guys agree with this? Stand up if you agree. Okay, stand up if you disagree. All right, Elizabeth, why do you disagree?
Because once it takes more people longer to do certain homework because there may be a different type of homework for that one, and so they might get different times, and homework doesn't take an hour for what. Well,
Okay, I need you not to use personal experience, I need you to use data. So looking at this data, disagreeing is correct, but why? Based off of looking at our data, why would we say that they spend the same number of hours is not true?
because there's a pattern in
I mean, there's kind of a pattern. Obviously, we start with the highest being closest to the 0 or to the 1, and it goes down. But guys, look at the data. It's what?
it's spread out.
It's spread out. It's fairly evenly spread out too, right? So we're gonna take a little bit of the data, starts higher, the lower numbers, and then spreads evenly out. Do we wanna say that it decreases as it spreads out? You guys know? It's up to y'all. This is I'm just trying to fine tune and add 2 things together. All right. So I disagree. Because we start high at 1 hour and decrease evenly as we move to the right. We'll just say it that way. All right, questions. How do you feel about looking at charts now and comparing and all that good jazz? All right, go ahead and glue both of these papers into your notebook. And then go ahead in your notebook and turn your page once you have this stuff glued in and title it Lesson 4 Cool Down. Alright, so again, you're gluing this in and then you're turning the page and writing unit 4, or sorry, not unit 4, lesson 4 cool down. And then on the next, so you're putting this on the left side, on the right side, you're writing dot, plot, homework. Because yes, you do have homework today. So much fun. Alright, I just passed out your cool downs. Once you complete your cool down, please make sure your name is on it. I have quite a few no names in my no name bin. Turn this into the first period bin and come get a homework for me when you are finished.